Good morning, all of you. Today we are going to discuss a new topic in the subject electromagnetic field theory. So our today's topic is electrostatic field. So there are two fundamental laws which are governing the electrostatic field. The first law is Coulomb's law and second law is Gauss law. So first we will discuss Coulomb's law and field intensity. So the Coulomb's law, which gives the idea regarding force between the 2-point charge. As the name suggests, the point charge. Many students ask question, what is this point charge? So that we will consider a charge as a point charge if the distance between these two charges is very large as compared to size. Therefore, if we take a point charge, it will make our analysis easier in the calculation of force of repulsion or the force of attraction. Now, we look at the figure in which there are the 2-point charge and the distance between them is r. If we look at the figure, there are the two charges q1 and q2 and the distance between the charges is represented by r. Then the Coulomb's law states that if there are two charges, that is charge q1 and q2, and the distance between these two charges is r, then the force of attraction between these or repulsion between these two charges is directly proportional to the product of the charge and inversely proportional to the square of distance between them. If mathematically we will remove this proportional, and if we remove this proportional, then there is a proportionality constant called k. That means mathematically we can express the force between the charge as F is equal to k q1 q2 divided by r square, where q1 and q2 are the charges, r is the distance between these two charges, and the unit of these two charges q1 and q2 is in Coulomb, and the distance, which is in meter. And the force between these two charges will be in Newton. The k, which is a proportionality constant, its value, which is equal to the 1 upon 4 pi epsilon naught, and the value of 1 upon 4 pi epsilon naught is 9 into 10 raised to power 9 meter per farad. If you look at the vector representation, if the point charge q1 q2 are located at point having a position vector r1 and r2, then the force between these two charges will be represented as F12 and F21. That means if we look at the figure, there are two charges, charge q1 and q2. F21 represent the force on charge q1 due to q2, and F12 represent the force on charge q2 due to q1. So according to Coulomb's law, the force on charge q2 due to q1, which is represented by F12, will be equal to q1 into q2 divided by 4 pi epsilon naught r square multiplied by unit vector AR12. Now the R12, which is written here, is the difference of position vector R2 minus R1, and R is the distance between these two charges, where R is equal to the magnitude of R12, and the unit vector AR12 will be equal to vector R12 divided by its magnitude. Now, if you have, this is the force between two charges. Now, if you have more than one charge, or we can say the n number of charges, then suppose we have a charge q1, q2, q3 up to n. Then we use the principle of superposition to find the force between all these charges on a particular charge. The principle of superposition states that if there are n number of charges, that is q1, q2, qn, are located at position vector r1, r2, r3, r4 up to rn, then the resultant force F on the charge Q located at point R is the vector sum of all the forces exerted on Q by each of the charges Q1, Q2, Q1. Mathematically, we can represent it as, you can see here in this figure, as we have seen the force between the two charges and the force due to n number of charges. I think now we are in position to define electric field intensity. So the term electric field intensity, which is represented by capital E, is the force which a unit positive charge experiences when it is placed in an electric field. In next lecture, we will see other law, that is Gauss law. Till now, thank you.